Welcome to 6th grade math. That was your homework that was due. Get ready for the lesson. 1 can of frozen orange juice concentrate is mixed with 3 cans of water to make 1 batch of orange juice. How many cans of juice and how many cans of water would you need to make 2 batches that have the same taste? So we know it's 1 for 3, 1 juice for 3 waters, so it'd be 2 juice for 6 waters if we were going to make 2 batches. Draw a picture to support your answers. So there you go. And how many cans of each to make 3 batches? 3 juice, 9 water. And there's our picture to prove it. Find the ratio in simplest form of juice to water needed for 1, 2, and 3 batches of juice. And what do you notice? 1 batch is 1 to 3. 2 batches is 1 to 3. And 3 batches is 1 to 3. The ratios are the same. Quantities found in the Get Ready for the Lesson can be organized into a table called a ratio table. A ratio table, the columns are filled with pairs of numbers that have the same ratio. So for the juice example, cans of concentrated juice, we're going to have 1 and 3. 2 batches will be 2 and 6, and 3 and 9. The ratios 1 to 3, 2 to 6, and 3 to 9 are equivalent since each simplifies to a ratio of 1 to 3. You can see this by simplifying each ratio. If we do 2 and 6, we get 1/3, greatest common factor 2. And with 3/9, we can get down to 1/3 if we simplify with 3. Equivalent ratios express the same relationships between 2 quantities. You can use ratio tables to find equivalent ratios or rates. Scaffolding questions. What is the ratio of stars to circle? We have 1 star and 3 circles, so we have 1 star to 3 circles, or 1 to 3, or 1/3. What is the ratio of circles to shapes? So there are 3 circles, but there are 4 total shapes. So 3 circles to 4 shapes, or 3 to 4, 3/4. What if I extend the pattern to include 8 shapes? How many stars and circles will the pattern have? 2 stars and 6 circles. How can you draw a pattern so the ratio of stars to circles is 2 stars to 3 circles, or 2 to 3? We have 2 stars and 3 circles. Equivalent ratios of larger quantities. Icing. To make yellow icing, 6 drops of yellow food coloring are added to 1 cup of white icing. Use the ratio table to find out how much yellow to add to 5 cups of white icing to get the same shade. So if we have 1 cup of icing and 6 drops of yellow, and we want to find a pattern and extend it, for 2 cups of icing, you would need a total of 6 plus 6, or 12 cups. So plus 1 plus 6, and that gives us 2 cups of icing, 12 yellow drops of yellow. If we do that again, we get 3 cups of icing, and then we add 6, we get 18 drops of yellow. And then if we go 4, and then we add 6, we get 24 drops of yellow for 4 cups of icing. And finally, we get to where we wanted to be, which is 30 drops of yellow for 5 cups of icing. Method 2, we can multiply each quantity by the same number. So since 1 times 5 equals 5, multiply each quantity by 5. And we multiply 1 times 5, we get 5 cups of icing. And we multiply 6 drops of yellow times 5, we get 30. So add 30 drops of yellow food coloring to 5 cups of icing. Check for accuracy. To check your answer for example 1, check to see if the ratio of the 2 new quantities is equivalent to the ratio of the original quantities. Choose your method. A patient receives 1 liter of IV fluids every 8 hours. At that rate, use the ratio table to find out how many hours it will take to receive 4 liters of IV fluid. So if we have 1 IV fluid for 8 hours and we find a pattern To receive 2 liters, you'll need to add 8 to 8 to get 16 hours. So here's our pattern: plus 1 and then plus 8 is 2 and 16. Plus 1 equals 3, plus 8 equals 24, plus 1 equals 4, plus 8 equals 32. Now we could do method 2. We multiply each quantity by the same number. Since 1 times 4 equals 4, we're going to multiply both times 4, and we get 32. So it will take 32 hours to receive 4 liters of IV fluid. The table ratio presents a series of equivalent ratios. Ratio tables can be completed to solve problems involving equivalent ratios, such as patterns or rates. It may take several steps to scale up or scale down to find a relationship between the equivalent ratios. You can also divide each quantity in a ratio by the same number to produce an equivalent ratio involving smaller quantities. Example, equivalent ratios of smaller quantities. So hot dogs in recent years, Takeru Kobayashi won a hot dog eating contest by eating nearly 54 hot dogs in 12 minutes. If he ate at a constant rate, use the ratio table to determine how many hot dogs he ate every 2 minutes. So we know he ate 54 in 12 minutes. So now we have to divide each quantity by one or more common factors until you reach a quantity of 2 minutes. So if we divide 12 by 2, we get 6. 54 by 2, we get 27. If we divide 6 by 3, we get 2. And 27 by 3, we get 9. So he ate 9 hot dogs every 2 minutes. Check your progress. Make cranberry jam. You need 12 cups of sugar for every 16 cups of cranberries. Use a ratio table to find the amount of sugar needed for 4 cups of cranberries. So if we have 12 cups of sugar to 16 cups of cranberries, and we divide each quantity by one or more common factors until you reach a quantity of 4 cups. 16 divided by 2 is 8. 12 divided by 2 is 6. And then if we divide 8 by 2, we get 4. 6 by 2, we get 3. So we need 3 cups of sugar for every 4 cups of cranberries. We could also divide 16 by 4 and 12 by 4 to get there in one step. 12 and 16, so we divide by 4, and we get the 3/4. Scaling, multiplying or dividing 2 related quantities by the same number. Sometimes you may need to scale back and then scale forward to find an equivalent ratio. Example using scaling. Cans of corn are on sale at 10 for $4. Use the ratio table to find the cost of 15 cans. So we have 10 and we want to find out what 15 costs. And there's no whole number by which you can multiply 10 to get 15. So scale back to 5 and then scale forward to 15. So we'll divide 10 by 2 to get 5 and 4 by 2 to get 2. And now we can get from 5 to 15 by multiplying by a whole number. So we'll multiply 5 times 3 and get 15, 2 times 3 to get 6. So 15 cans of corn would cost $6. Check your progress. Height, a child's height measures 105 centimeters. If 25 centimeters is about 10 inches, use the ratio table to estimate the height in inches. We have height centimeters 25, height in inches is 10, and we want to find out what 105 centimeters equals. And there is no whole number to get from 25 to 105. So we are going to take it in 2 steps, and we're going to go back to 5, just like we did previously. 25 divided by 5 is 5. 10 divided by 5 is 2. And now that we have a number 5 that will go into 105 evenly, we can multiply 5 times 21 to get 105, and 2 times 21 to get 42. And now we know that 105 centimeters is approximately 42 inches. Use a ratio table. On her vacation, Leah exchanged $50 American and received $90 Canadian. Use a ratio table to find how many Canadian dollars she would receive for $20 American. So 90 Canadian dollars and 50 American dollars. And we need to find out how much Canadian would it cost to get 20 American. And there's no whole number that can get us directly from 50 to 20. So we are going to scale back to 5 and then scale forward to 20. So if we do 50 divided by 10, we get 5. 90 divided by 10, we get 9. And then we can multiply 5 times 4 to get 20, 9 times 4 to get 36. And we now know it costs, you would have to exchange 36 Canadian dollars to get 20 American dollars. That is not an updated exchange rate. Automobiles. Landon owns a hybrid SUV that can travel 400 miles on a 15-gallon tank of gas. Use a ratio table to determine how many miles he can travel on 6 gallons. So he can go 400 miles on 15 gallons of gas, and we're trying to figure out how far he can go on 6. We need to get from 15 to 6 and then make the same adjustment from 400. So there's no whole number that can get you right from 15 to 6. However, if we were to scale back and then scale forward, so if we divide each quantity by a common factor of, let's say, 5, we get to 3. And if we do 400 divided by 5, we get to 80. And now 3 will go into 6, so we can multiply 3 times 2 and get 6. 80 times 2 and get 160. So Landon can drive 160 miles on 6 gallons of gas. Additional examples. A recipe calls for 5 cups of water for each cup of pinto beans. Use the ratio table to find how many cups of water should be used for 4 cups of pinto beans. So method 1, we'll find a pattern and extend it. For 2 cups of beans, you'll need 5 plus 5 or 10 cups of water. So if we add 1 cup of beans, we're going to add 5 cups of water. If we add 1 cup of beans, we'll add 5 cups of water. And if we add 1 cup of beans, we will add 5 cups of water. So multiply each quantity by the same number for method 2. And hopefully remember that multiplication is just repeated addition. So it should make sense that we can multiply 1 times 4 to get 4, and then multiply 5 times 4 to get 20. So you will need 20 cups of water for 4 cups of beans. Table ratio represents a series of equivalent ratios. Ratio tables can be completed to solve problems involving equivalent ratios, such as patterns or rates. It may take several steps to scale up or scale down to find a relationship between the equivalent ratios. And that is just a reminder from earlier. Spiders. Texas has over 900 species of spiders. Use the ratio table to find how many legs a spider has. So, number of spiders, 4. There are 32 legs because each spider has 8 legs. But if we didn't know that, we could say 4 divided by 2 equals 2 spiders, and we can divide 32 by 2 to get 16. And then we could divide 2 by 2 to get 1, and 16 by 2 to get 8, and a spider has 8 legs. We could also divide 4 by 4 and 32 by 4 and get there in one step. 4 divided by 4 is 1, 32 divided by 4 is 8, and we would do that to get the number of spiders to 1, so that we would have some kind of unit rate. Clothing. Coco used 12 yards of fabric to make 9 blouses. Use the ratio table to find the number of blouses she could make with 20 yards of fabric. So she has 12 yards of fabric, she can make 9 blouses. If she has 20 yards of fabric, she can make how many? So we can't get there in one step, 12 to 20. So we're going to go backwards to 4 and then scale forward to 20. And 12 divided by 3 gets us to 4. 9 divided by 3 is 3. And now that we have 4, we can multiply 4 times 5 to get 20. And then we would have to multiply 3 times 5 to get 15. So Coco can make 15 blouses with 20 yards of fabric. It takes a worker 70 minutes to pack 120 cartons of books. The worker has 14 minutes of work left. Use a ratio table to find how many cartons of books the worker can pack in 14 minutes. Cartons, 120 120 cartons of books in 70 minutes. And there's no number we can divide 70 by, no whole number we can divide 70 by to get 14. So we will take it in 2 steps, and we're going to scale back to 7 minutes, and then we'll scale ahead to 14. And that'll make it easier for us. So 70 divided by 10 is 7, which means 120 divided by 10 is 12. And now 7 times 2 is 14. So 12 times 2 is 24. The worker can pack 24 cartons of books in 14 minutes. Relating to everyday tasks, so we have 2/3, 4/6, 5/7, 6/9, and 8/12. Which fraction doesn't belong? Which fraction doesn't belong? 5/7. Do you know why? It's the only one that isn't an equivalent fraction there. 1/4, 2/8, 3/12, 4/15, and 5/20. Which fraction doesn't belong? 4/15. And how did you determine which fraction did not belong in each group? By scaling. We multiplied or divided the numerators and denominators by the same number. How did you know which fraction did not belong in each group? Numerator and denominator 5/7 shared no common factors with the numerator and denominator of 2/3. They were not equivalent. And the numerator and denominator of 4/15 shared no common factors with the numerator and denominator of 1/4. So they were not equivalent. There's your homework. Head on over to Google Classrooms to submit it. I hope you have a great rest of your day, and I will see you in class.